Messenger is using a process called orbital insertion. The spacecraft has to slow down enough so that the gravitational pull of Mercury will capture it, pulling the spacecraft into orbit. To help it slow down, Messenger uses gravity assist. Gravity from Earth, Venus, and Mercury has slowed Messenger down during the early stages of its journey. Eventually, in March 2011, with the additional aid of onboard propulsion, it will slow to the point where it will be pulled into orbit around Mercury. This is NASA's second mission to explore Mercury and its first visit in more than 30 years.
Back in the 70s, the Mariner 10 mission was part of a whole series of missions from NASA that was trying to survey the galaxy.
Eric Finnegan is the mission systems engineer for the Messenger mission.
Those missions were designed to just fly by and figure out what's out there. From that data, it piqued everybody's interest to see Mercury in its first time, these various interesting artifacts. They saw a magnetic field which they didn't expect to see. They saw pictures from the surface that kind of looked like there should be volcanism, but they didn't know.
So Messenger was launched to answer these questions and to learn more. And although it won't orbit until 2011, the spacecraft has already sent us some amazing data during its preliminary Mercury flybys.
With both Messenger flyby number 1 and Messenger flyby number 2, now we've seen a good 90% of the surface and definitely concluded that the planet has evolved using volcanism as one of its prime processes.
Volcanism is activity from volcanoes that erupted and spilled materials onto the surface of the planet.
We've also seen a lot of shrinkage of the planet, so we know the planet's been cooling, so we do believe it has some sort of core.
Volcanism and shrinkage make it similar to Earth. Evidence of shrinkage can be seen in photos from Messenger showing cliffs on Mercury's surface. All these discoveries on Mercury shed light on the history of our planet.
Well, we can look at models of the Moon, we can look at models now at Mercury, and we can look at models of, let's say, Mars, model all those planetary structures in different periods of time and create an understanding of what might be happening here at the Earth, or what might happen in the future from here at the Earth.
And these lessons we are learning now are just the beginning. Messenger is just getting started.
This is a 1/10 model of the Messenger spacecraft. The regular spacecraft's about as big as a small car. The Messenger spacecraft's flying almost as close to the Sun as anything that's flown before. It's 2/3 closer to the Sun than we are here at the Earth. When you're at Mercury, you feel the Sun about 11 times hotter than you would here at the Earth. So just to give you a feeling of being out on the beach, you'd be 11 times hotter than that. It's very, very intense.
Being that close to the Sun is good and bad. Good for solar power, but bad for the spacecraft because it is so hot. Messenger has many innovative features that allow it to get close to the Sun without burning up. For instance, its solar panels not only absorb the Sun's energy to power scientific instruments, they also reflect much of it away from the spacecraft.
What they have is optical reflectors, so the energy hits the solar array and then re-radiates it back without collecting it on the array itself, so it keeps the panel itself cooler. One other thing we do from a geometrical perspective, when we get closer to the Sun, we actually tilt the panels away from the Sun.
Messenger also has a ceramic sunshade that helps keep it cool under the circumstances.
The differential between the front of the sunshade and the spacecraft is this is about 300 degrees Celsius on this side, whereas the spacecraft's maintained at basically room temperature. So that gives you a feeling for how much thermal protection we have on the spacecraft.
In addition to all the thermal protection, Messenger is also loaded with tools for gathering scientific data.
At the end of this, what we call the magnetometer boom is a magnetometer.
This instrument helps scientists learn about Mercury's magnetic field in detail, providing information about the field's strength and how it varies with position and altitude.
We have to set it this far off from the spacecraft because the spacecraft itself generates a magnetic field, and we want to separate the magnetic field of the spacecraft from the magnetic field that the sensor might be sensing. So all of these sensors are mounted mostly on the back end of the spacecraft. So as it flies around the planet, we put one surface of the spacecraft to the Sun, one surface of the spacecraft to the planet. It maintains that orientation almost throughout the entire mission. On the back of here is where our main sensing instruments are. There's a dual camera. We call it MDIS for Mercury Dual Imaging System. It has a narrow field of view camera and a wide field of view camera. And that's where most of, if not all of our pictures come from.
The wide-angle camera can observe Mercury through 11 different filters. The narrow-angle camera takes high-resolution black and white images, allowing for extremely detailed analysis of features as small as 18 meters across. You can see thousands of those amazing photos and follow Messenger by visiting www.nasa.gov and also at messenger.jhuapl.edu.